Hello everyone. So I wanted to address a question that I often get from my students, and that is why doesn't my Turing machine reduction loop infinitely, even if in the definition of the reduction we have the possibility of such an infinite loop. So let's look let's look at the reduction from ATM to E bar. Okay, the problem definition just is this. So ATM is the acceptance problem, and we're trying to decide whether M accepts some input W. And the empty language problem is where we are trying to decide whether a Turing machine doesn't accept any input at all. And the complement of E is trying to decide whether E accepts any input at all. So the reduction is given an input for ATM, which is M and W, the pair M and W. We want to create a Turing machine M that is either accepts the empty language. If M accepts W, then M accepts some string. If M doesn't accept W, then M doesn't accept any string at all. What we do is we construct a new Turing machine based on M and W. We simulate M on W. If M accepts W, we accept. If M doesn't accept W, we reject. Okay, but note that M can also not accept W by the means of simply entering an infinite loop. Okay, and here's where the question that I get often arises. So why is this not a problem? And the answer is that it is similar to simply writing a function that enters an infinite loop. Think of it as something like this. Okay, I can write this function that loops infinitely. Okay, while true, do something. The fact that I have written a function that when actually this code is executed actually enters an infinite loop doesn't mean that this in itself is a problem. It's not an infinite loop in itself. Okay, and in very much the same way, when we look at this line in the reduction definition, it says that if M does not accept, okay, if M does not accept, it either rejects and then we reject as well, or it enters an infinite loop, in which case the machine M prime enters an infinite loop as well and does not accept the input. The resulting situation is that we get this connection. If M accepts W, that is, if M and W, the pair M and W belong to ATM, then M belongs to, well, to the complement of E. Because if M accepts W, then our new machine, M prime, also belongs to complement of E. But if M doesn't accept W, be it via rejecting or via entering an infinite loop, the result is the same, and M prime does not accept any input. I hope you found this video helpful, and I will see you in the next videos. Have a nice day.